Hello, everyone. This is the lecture for section 3.4, graphs of polynomial functions. So up to this point, we've been messing with a lot of polynomial functions, right? And getting to learn the bits and pieces of it, right? We're going to tack on a couple more things that sort of have to be done sort of separately, but still tie in with the stuff that we've done from section 3.2 and 3.3, okay? Uh, On here, we're going to learn how to identify zeros just in general now, and we're going to introduce something called the multiplicity and some other stuff about polynomial functions, the graphs of them that make them just nice functions to work with. Okay, so the first thing that I want to point out is just the niceties that we have for polynomial functions. Okay. Uh, the first thing that makes polynomial functions so nice is this that polynomial functions tend to not have sort of like kinks or sharp points or sharp edges anywhere. Okay, and for that we call this is something that you're going to hear when you get to calculus. We call them smooth functions. Okay. The next thing that we have about polynomial functions that's nice, right, is that it has no jumps. Okay. Uh, and for this is another term that you're going to learn in calculus, that these functions, polynomial functions, tend to be continuous. Okay. So usually the graphs of polynomial functions will look something like this one and this one. Okay, graphs that look like these two, right? This one has a very sharp edge there, right? And this one's got a jump. Okay, so these two wouldn't be polynomial functions. They look like they would, right? But they're not. Okay. Okay. So now let's get into the real nitty gritty of this stuff. Okay. Factoring and using calculators to find zeros of polynomial functions. So for to start, we're going to start with a real nasty one. We're going to start with a nasty polynomial, this one right here. Okay. Now, it's asking us to find the zeros, right? And on the right, hopefully you guys see this thing, we have a graph for it. Okay. So from the previous couple of sections, right? Hopefully you guys remember that because of the graph, we have a fair amount of information that we can sort of reverse engineer for our function, right? Okay. So in particular, right, from what we're looking at here, okay, I'm going to go ahead and just use that knowledge from the previous section, right, to build the function itself. Okay. So I want everybody to notice this, right, that there is one, actually, let me not do it in yellow. Let me do the other 5 colors that I got. 1, 2, 3, 4, 5. I've got 5 zeros there. I have 5 x-intercepts, right? And from the previous section, we can build our function, we can build the polynomial based off of these 5 points, okay? So I'm going to go ahead and write it out, and then I'm going to highlight the different points, okay? One of them, the blue one, that's negative square root of 2 comma 0. Okay, so that is going to be, if you guys remember, right, x plus the square root of negative 2. Whoops, sorry, plus the square root of 2. Okay. The next point is going to be x plus 1. The next point after that, you guys see that pink one, it does cross 0, 0, so that should be x minus, or x, yeah, x minus 0. Okay. The next one over is going to be x minus 1. And the next one after that is going to be x minus square root 2. Okay, so let me highlight each one as it went across, right? Bam. That one was that one. That one's that one. Just to color code them so we keep sort of a track of our thoughts there. All right, there we go. Those are all of our x-intercepts, right? Okay, what I'm going to do now is I'm going to expand this out, okay? I'm going to expand this out. And the way that we're going to expand it out is this. I'm going to rearrange some stuff first and simplify stuff first before we do that. So this x minus 0, I'm going to stick that in front. That's going to be x. And then I have pairs, an x plus 1, x minus 1. So x minus 1, x plus 1. Got it? And then I have an x plus root 2 and an x minus root 2. So I'm going to pair those two together. Okay? X minus root 2, x plus root 2. Okay. All right. So now, what I'm going to do is this. I'm going to sort of distribute these. I'm going to FOIL this out. Okay? And then I'm going to FOIL these two out. Okay? So that produces this. The x up front is going to come along for the ride, basically, right? These two together are going to produce x squared minus 1. Okay? And the next two together is going to produce x squared minus 2. Okay? So let me highlight now, right? Actually, let me not highlight. Let me leave it like that. Okay? So basically saying, right, that this one made this one. Okay? And then this multiplication made this one. Okay, we've got our ducks in a row, right? Okay, I'm going to FOIL again. Like I said, I wanted to expand this entirely, right? So I'm going to expand these two now. I'm going to grab these two and multiply them out, okay? So then this is going to be this, right? X times. I'm going to use FOIL, so the first two, so x to the 4th, right? Minus 2x squared minus x squared plus 2. Okay, and this simplifies down to the x state. It's coming along for the ride anyway, right? X to the 4th. There's a minus 2x squared and another minus x squared. So that's going to be minus 3x squared plus 2. Okay, and now I'm going to distribute in that x. So this final x that's up front, the one that was coming along for the ride this whole time, this one I'm actually going to distribute in. And I get this. X to the 5th minus 3x to the 3rd plus 2x. We simplified it all out. Bam. Yes? Now, what I want everybody to notice really quick, now that we're here, okay, is this. It is not the original. The numbers are, the coefficients up front, the numbers that are up front on each term, they do match up, but the powers don't. So something funky is working its magic here. We don't know what it is yet. Okay, but for the most part, from what you guys remember from the previous sections from chapter 3, this is it, right? So keep this in mind, because we're going to come back to this one. Okay, we're going to come back to this one. Okay, let's move on. I want to show you guys another example. Let's do one that should look familiar now, right? This one. Okay, again, I'm giving you the graph. Okay, it's over there on the right hand side. And we have, let me do it again, 1, 2, 3 zeros. Okay, 3 zeros. So based on what we remember from our previous sections, right, my f of x right? Seeing the zeros that we have over here, we should be able to write something out that hopefully looks like that, right? So if we write this out, if you guys see, that's minus 3 comma 0, minus 2 comma 0, and this one over here is 1 comma 0. So we have our zeros, we have the roots. So that means that our factored form is going to look something like this, right? X plus 3, X plus 2, and then X minus 1, okay? Let's go ahead and expand this out. So I'm gonna do the foiling for everything, right? So the first foiling I'm gonna do is these two, okay? And that's going to be equal to x squared plus 3x plus 2x plus 6. And then for right now, the x minus 1 gets to come along for the ride. If I reduce this down, right, x squared plus 5x plus 6 times x minus 1. All right. I need to expand this now, right? Okay. And that means I have to multiply each one of these by everything in this big one. Does that make sense? So those 3, and then I have to do these 3. So this is foiling. Okay. Okay. So keep a track of your thoughts. Okay. Write it down on a piece of paper. Don't do too much in your head. Okay. So the first, I'm going to get x cubed, okay, plus 5x squared plus 6x, okay, plus, now here we go, okay, it's going to be minus 1 times x squared, so that's going to be, and I'm just going to make this negative, so minus x squared, minus 1 times 5x, that's going to be minus 5x, and then minus 1 times 6, minus 6. Okay, this cleans up. X cubed, there's an x squared here, there's 5x squared here, there's a minus x, so that leaves me with 4x squared. Okay, there is a plus 6x and a minus 5x, so it's going to be plus just one single solitary x minus 6. That's the only thing that's left off without anything to combine with, right? Now, look at this. You guys see that? That and that do match up. The result from our function turns out to be the original function that we were playing around with to begin with, right? Okay? All right. Now, what I want everybody to notice is we use the same process. We use the same steps, right? In this example, as we did with the example before this one, right? Okay? In this one, we got the correct answer. We got the function back, right? But in this one, we didn't. So WTF, right? Now, I want everybody to take a look at this. And this is what we're going to cover. This is what I'm going to cover in a little bit. Notice that all of these zeros, all of these x-intercepts that we found, right? Okay, I want everybody to look at those x-intercepts, okay? And I want everybody to look at these x-intercepts. One of them is not like the others, okay? So pause the video and go back to the notes and look at them, okay? And I'm going to give you guys the answer right now. All of these zeros for both of these. So I'm going to go back to this one. You guys notice these zeros, right? They actually cross the x-axis for the graph, right? And if we go back up here, these and these cross the x-axis, right? It's this one that bounces. That's what we want to say. It just touches or bounces. It just, the best way I can explain it is it goes like this. It goes doink and then shoots back off. Okay? So it doesn't actually cross it. It just sort of like bounces off of the x-axis. This one's the one that's different. That one. Okay? Okay. So now, let me continue on with the notes, and this will be rounded out with the notes that I'm about to cover. So identifying zeros and their multiplicity. So now we're going to get into the multiplicities of a zero. Okay. The first thing I need to cover is this fundamental theorem of algebra. And I did cover it already, I believe, in section 3.3. Okay. The statement of the fundamental theorem of algebra is this, that the number of roots or x-intercepts of a polynomial is exactly its degree. So if you guys remember, the degree of a polynomial is the highest power you see. Okay? It's the highest power that you see. There is a caveat with this statement for the fundamental theorem of algebra, right? Is that it does not take into account repeated roots. Okay, so this can include repeated roots. Okay. Okay. A definition that I need to cover. Okay. The number of times a given factor appears in the factored form, when you have a bunch of stuff multiplied by itself, like this one, like this. This is the factored form. When you have a factored form like this, okay, and we need to the times that it appears in the function, right? That is called its multiplicity. Okay? Okay. Something pretty nice happens when you talk about multiplicities. Okay? Single zeros, single roots, will look like this. It'll just flat out cross it nearly straight line. Okay? Zeros, roots with multiplicity of 2 will look like this. They will bounce off. Okay? Zeros with multiplicity of 3 will have a squiggle sort of that goes through them. Okay? Hopefully you guys see a pattern here, right? In particular, let me change the color of this one. I'll make this one pink, right? Okay? Hopefully you guys see the pattern already. I'm going to write it up down below here. The zeros with even degree, the zeros with even multiplicities, right, will only touch or bounce the x-axis. It'll just sort of touch that point and then bounce back off. It'll just go back where it came from, right? It's the odd ones, if you have an odd multiplicity for a zero, right, that will cross it. Right? Okay. The single zeros would cross it like this, right? And the odd one, or sorry, the single zeros cross it like this. And anything bigger than that will look like a squiggle. Got it? Okay. So now, let me show you guys an example. And this is powerful stuff here. Okay. So let's say I was given a polynomial. So hopefully you guys see this. Here's my function, right? Okay. So I'm going to make a table here. Okay. And this thing is asking us to determine each factor, find each root, and determine whether it crosses or touches the x-axis. Okay. And then we need to provide a rough sketch. Okay. All right. So I'm going to make a table. Okay. I'm going to do this. It's going to be factor, root. I'm going to do touches or crosses. You guys, hopefully that makes sense as a table. Okay. In this case, they're just two factors, right? So the first factor is going to be the x. Oh, I forgot one column here. Multiplicity. And then touch or cross. Okay. The first factor is the x plus 3. Okay. The root for that factor is going to be x equal minus 3. Okay. That means we have to grab this, make it equal to 0, solve, blah, 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 blah. Okay. Got it? The multiplicity of it is 2. And since the multiplicity of it is 2, that means this is going to touch. Okay? The next factor, x minus 5. My root is going to be x equal positive 5. This multiplicity is 1. So if you have, hopefully you guys see that, if there's nothing listed, you can assume that it is a 1. Got it? Okay. And since the multiplicity is 1, it'll cross. All right. Simple enough, right? Okay. I'm going to move this up a little bit, okay, because I'm going to do this. I'm going to grab f of x minus 2x plus 3 squared x minus 5, okay? What I'm going to do is expand it out. I'm going to completely expand it in all its glory and all its nastiness, okay? So minus 2, I'm going to do this bit first. I'm going to do the x plus 3 quantity squared. So if you expand that out, I'm going to get x squared plus 6x plus 9 minus 5, x minus 5. That one is just coming along for the ride, but now I'm actually going to expand it out, okay? Minus 2, I'm going to go ahead and do the multiplication here, okay? This is going to be x cubed plus 6x squared plus 9x minus 5x squared minus 30x minus 45. Got it? Okay, I'm going to simplify. Minus 2. X cubed, there is an x squared here and an x squared here. So if you take a look, it's 6x squared minus 5x squared, so it's going to leave me with plus one single solitary x squared. I've got a plus 9x and a minus 30x. Okay, so that leaves me with minus 21x, and then the minus 45. That just comes along for the ride. One last step left. I've got this minus 2 out front that I want to distribute in. So, minus 2x cubed, okay, plus 2x squared minus 42x, oh, plus 42x, sorry, plus 90. So, these two equations, it's my final answer here, right? Okay, these two equations right here, this one and this one, are entirely the same thing. Okay, now, here's the nicety of having multiplicities now, right? Because of this table, we know what each x-intercept will do. Okay, so we can actually graph this now without using a graphing calculator. Okay, so follow along here, right? Because of this function, because of this version, right, this graph is going to be something that looks like x cubed, right? So that's going to be a squiggle. It's going to be one of these, a whoosh, right? It's a negative 2 up front, so this is going to be an upside down squiggle. So we get to flip it. It's going to look like this. Okay, and now we have this added benefit that because of this, because of our table, because of this table, we know where the roots are going to be and what they're going to do at each root, whether it's going to touch or cross. Okay, so here we go. I need a function that looks like this. I need to draw something that looks like this, right? That touches at x equal -3 and crosses at x equal 5. It can be rough. That's okay. Okay, so same thing for you all when you do this on your homework. If you want to be very, very, very precise, go ahead. Okay, I'm not going to be too crazy about that. Got it? Okay, so it's got to cross at -3 right here. It's got to have an x-intercept at -3. And actually, let me use another color. I'm going to use this orange. Here's 1, 0. And the other one's going to be at 5, way over here. Okay? But here, it's supposed to just touch it, right? And here, it's supposed to cross it. Okay? So hopefully you guys see how this is going to work. And it's got to be an upside down squiggle. You guys see that? So this would be a perfectly good response to this question. Whoa, let me touch it. Go back up. Bam. This is a perfectly good rough sketch for this kind of graph. Okay? Simple enough, right? So now, what I want to do is I want to go back to my initial problem. The original, this one. So remember, I said this root right here, the one at 0, 0, that one's the one that didn't belong, right? This should automatically now that we know, this should tick everybody off to what's missing. What's missing here is this. Since that root bounced off, that root, the factor for it, should have been squared. So that means this should be squared. This should be squared. This should be squared. This should be squared. And now you guys see, right? I'm going to write it over here. Now you get x to the 6th minus 3x to the 4th plus 2x squared. Now we actually get the right answer. We get the answer that we were supposed to get from the beginning. Got it? All right. We're getting somewhere. What comes out after this is some quick checks. I'm going to give you guys some functions that I'm going to have you guys figure out, right? And then after that, it is lecture questions. If there's any questions on the material that I just covered, ask me during class or come to my office hours. Besides that, happy studying.